We're going to look at how to write the equation of a geometric sequence given two random terms in the sequence. Here's what we have. We have the fifth term is -4, the 10th term is -128. There's multiple ways you can solve this problem. One way is to look and see, to get from the fifth term to the sixth term, we have to multiply by r, the common ratio. To get from the fifth term to the seventh term, we have to multiply by r squared. To the eighth, r cubed. So what we're going to end up doing is multiplying -4 by r to the fifth to get -128. But the way that we could always get that is by subtracting the difference of the terms. Term 10 minus term 5 equals -128. And then we can divide by -4 to both sides. So technically, if you wanted to start at this step, you can always do the common ratio to the term number minus the term number in the exponent equals the term value divided by the term value. But what we did before kind of explains why we can do that. Before I continue solving, I'm going to show you another way you could start that off. You have the general equation, and you plug one of your terms in, and you pick the one that has the higher term number first. So a sub n, a sub 10, the value of the 10th term is -128 equals a sub 1 times r to the n, term number is 10 minus 1. And then you do the same thing again, but with the other one. So then first you can simplify both of those a little, and then you can divide these two equations. When you divide variables, you subtract their exponents, so 9 minus 4. Notice at this point, we're left with the same thing that we have here. Because in your next step, you could simplify -128 divided by -4r to the fifth. And same with over here, you get 32 equals r to the fifth. And now at this point, you can just continue to solve. To get r by itself, we can fifth root both sides. We get r equals fifth root of 32, which equals 2. If you remember how we would solve for this type of problem when we were given an arithmetic sequence, we would first solve for the common difference. And in this case, we solved for the common ratio. And then the next thing we would do is solve for the first term or the 0th term, depending on what general formula you were using. So that's what we're going to do here. The general formula we have is a sub n equals a sub 1 times r to the n minus 1. So we can solve for this first term now by plugging in the common ratio and then picking an n and an a sub n. So if we pick the one with the lower numbers, a sub 5 or the fifth term value is -4, and then the term number n was 5 that we can plug in, minus 1. Now we only have one variable, so we can solve for a sub 1. 5 minus 1 is 4, 2 to the fourth is 16, and then we can divide by 16 to both sides. So a sub 1 is -4 over 16, which is -1/4. Now we can plug in r and a sub 1 into our general formula, leaving n and a sub n as n and a sub n. A sub n equals -1/4 a sub 1 times r, which is 2 to the n minus 1. And remember, you cannot combine the -1/4 times 2 because 2 has an exponent.